All right, everybody. Good afternoon here. Let's see who we have. We have at home, we got Panawat at home. Good afternoon, or good morning, sorry. Blanca, don't even know what time of day it is. Eric, good morning. And Caesar, good morning. So good morning to all you guys here. Good morning to everybody here. It's not raining anymore, so I guess that's a good thing. I don't know. I kind of like the rain personally. I mean, we don't get it in LA, right? We definitely need water here throughout the nation. I think I think the Mississippi's drying up even, So anyway, all right. So ladies and gentlemen, we got a very important topic called power reducing formulas, right? And this was brought to my attention. So I'm glad because I don't want to forget that. But let's go back to where they came from, if you guys remember this here, right? So we did derive those formulas, and I think that was all the way in the beginning. And I don't know, there's something about this thing that just trying to get to the beginning here. Oh, whatever. We can write them down ourselves. Okay, so here's kind of the beginning, I think. Yeah, there we are. And then at some point I said, hey, by the way, these are the power reducing formulas. You go, power reducing, what does that mean? We can reduce powers. Now, it's an important idea, and I guess I'm just going to go back in my own sheet and write it down. You guys can check your notes, whatever. It's important in future processes and even in working with some science, right? So here's what I want to remark here for you guys. We have sine squared theta here. You can see it a couple of ways. It's 1 minus cosine 2 theta over 2. And then you have cosine squared theta is 1 plus cosine double theta over 2. Okay? You do have a tangent version, but I got to admit that I have not used in my life the tangent, version. We can write it down. You can check the book as often as I've used these two. I mean, these two by far. So, I'll write it down, I guess, just for consistency's sake. And all it is the ratio of the two that we have above. So we actually prove these this week. So if you guys recall, these are also proven. So we derived these, if you guys remember. Okay, so that's in our notes. Should be. But then the question becomes, how do you use these? And I want to remark, though, on the left side, you all have power, 2? Okay? And on the right side, you might say, what's your power on the right side? You don't see a power. But what does that mean if you don't see a power? That's always default, the power 1, yes. So you say, well, I don't see a power. Well, that's 1. Okay? Easy breezy, lemon squeezy. So just by definition of these power reducing formulas here, okay, these three, we got here power 1, it's there. Right? This is the power reducing formulas, really mainly the first two. So when I look at your book, and I'm going to try to do something here, I think I like even questions a lot of times. So, okay. So you might say, my book said to me, hey, as an example of how to use these power reducing formulas. You got cosine to the 4th power here, okay? How do we reduce these powers? And it is such an important thing. If your guys going to plan on taking a calculus course, maybe, and specifically calculus 2, we use this. And you go, oh, is that why you're talking about this? Yeah, we use it because in a calculus 2 course, there's processes that involve power reducing. So like I even have a video online in the Calculus 2 setting that does this power reducing, but it does it in like a Calculus 2 setting, you know. And I can share with you what it is. You guys don't have a Calculus 2 setting. A Calculus 2 setting, just to kind of remark, would be, what would you do if you have like, you know, you got to reduce the power and then you have like 3x there. So that would be a Calculus 2 version that you can see. And they assume you know how to do it from the what? The trig version. Okay, so just so you guys know, you say, hey, do I ever see these things? Because I've always felt it's important to give people what they'll see in the future. So they're aware and they can actually, you know, succeed. That's the whole idea. So anyway, let's kind of do the trig version. We're not going to do the Calculus 2 version. But like if you take that course, they're going to assume you know how to do the trig version, right? So that's the whole idea. So, and it's all based on, I hate to say this word, this mean word, it's based on algebra. Ooh. The topic that people say we don't even care about, right? Algebra, who cares? It's like, ooh, don't say that. I'll have a heart attack. So we're going to use this idea here, okay? So let me kind of talk a little bit about the algebra, okay? Do you guys remember? These are like, going back to algebra, I'm going to say, if you guys remember, a squared times a squared. This is the S portion of the course. Do you guys know what that is? That's a to the fourth, is that right? By properties of exponents? So I'm going to put a little bit of our algebra in honor of the S portion. And so you might say, is this 2 plus 2 being the 4 value you're talking about? And the answer is yes. Okay, you guys okay with that? Now you might say, what do I do with this? Well, go back and take a look at your power reducing formulas here. Okay, you're going to use this cosine squared version. Now, when I use this version personally, I'm going to say I write it this way. I think this is much more easier to use, and I'm going to put it below there, okay? This is the easier version to use. I'm going to erase this, and I'm going to erase this, because they don't even give you examples with tangent. And I'm going to give you the more useful version. This is 1/2 1 plus cosine 2 theta, okay? This is more useful. That's the same though. Okay, so I factored out that 1/2 really. This is more arithmetically easily, is there a word arithmetically? This is easier to use with your arithmetic. So this becomes here. 1/2 1 plus cosine 2 theta. And this is the same. This is what? 1/2 1 plus cosine what? Double theta. Okay? So the price that you pay for using this identity is that you now have double theta. You know, it's the price you pay. And then you say, okay, Mr. Judge, what happens now? I'll say, look at the arithmetic. Okay, I'm going to switch the order. The order in which you multiply doesn't matter. So this is going to give you now what? Yeah, it'll give you 1/4 now. Now you have 1 plus cosine what? 2 theta. 1 plus cosine what? 2 theta. All right, you guys okay with that? Now I'll say, what do you guys do here? What do you guys think you use here? Right? What do you use right in here now? What do you guys think that is? You have to use what? You have to use FOIL, is that right? So how do you use FOIL? And in fact, this is a very special version of FOIL. Okay, this is first, outer, inner, last. What you're going to end up with here is a squared plus 2ab plus what? Plus b squared. Okay, so just going to go back and say this is where the 1/4 came from because it's 1/2 times 1/2. So again, this is the algebra you use, this very special formula here. So now you have the 1/4. Now what do you guys get? You guys know what you get? 1 squared plus 2 times 1 times cosine 2 theta, right? Plus cosine squared what? Double theta, okay? I just use that formula. It's really 1 plus 2 what? Cosine double theta plus cosine squared 2 theta. Okay, you guys okay with that? So we expanded by using, FOIL. This is called an expansion. Now, take a look at what you see here. Okay? You got a cosine square theta. When they say power reducing, by the way, if I didn't say this here, they'll say, what's the instructions? Use formulas for lowering the powers to rewrite the expression in terms of the first power of cosine. So when they say, they don't say power reducing, they say write as a single power of cosine. That's really what it is. And what you do is you use power reducing formulas. Now, when you say a single power of cosine, yeah, that's cosine to the first power. Okay, you guys with me on that? That's cosine to the first power. That's what they're saying. What do you guys notice over here, though? This is not cosine to the first power, is it? It's cosine squared. Is that right? Okay, so here's what I'm going to say to you guys. I'm going to do this kind of easy. This is my approach. Distribute your 1/4, okay? Do that first. What that means is you end up with what? What's 1/4 times 1? You get 1/4 plus, what's 2 times 1/4? 1/2 cosine double theta plus what? 1/4 cosine squared double theta. All I did was distribute my 1/4. And so you say, Mr. Judge, why did you do that? What do you guys think I did that? What's the real reason? You guys know why I did that? Because what do you think I'm going to do here with cosine squared? We're going to have to do what here? Yeah, we're going to have to use the power reducing formula. Again. Okay, so far so good. You got to use that again. Now, you say, well, how do we use this thing again? You guys know how we use it again? Be careful here. You got cosine of what? 2 theta. What does the power reducing formula actually do? I know I gave it to you in terms of a single theta, but notice this. Here's the angle theta, okay? This is double theta. It doubles that angle, doesn't it? So if we're going to use this again, and that's what we have to do, this portion, again, notice what this will be here, okay? This will be 1/2, 1 plus what? Double 2 theta. What's double 2 theta? 4 theta, okay? Doubling 2 times 2 theta is what? That's my point to you guys. That's the orange that I'm saying here. So anytime you use the formula, you double the angle. All right, you guys okay with that? Every time you use the formula, you just double the angle. So now you say, what do I do with this? Here's what you guys do. You take what? 1/4 plus what? 1/2 cosine double theta plus 1/4 now times what? This whole thing here. All right, you guys okay with that? And what do you do with these numbers here? One fourth plus 1/2 cosine double theta plus, what's 1/4 times 1/2? Do you guys know? Is that 1/8? 1 plus cosine what? 4 theta? Easy breezy lemon squeezy. Okay. Okay, so that's kind of the move. This is going to make everything a little easier. So following it this way makes things easier, because what do you guys get to do now with this 1/8? You guys know? What do you do with that? You get 1/4 plus what? 1/2 cosine double theta plus what? Plus 1/8 plus 1/8 cosine what? 4 theta. Easy breezy lemon squeezy. Okay. You guys okay with that? We distribute. Now, maybe you said, I want to see a algebra formula for distributing, right? Remember, if you have a sum, this is A times parentheses of B plus C. Isn't that AB plus AC, right? That's what I mean by the algebra, these algebra formulas that we use. And then we get what? 1/4 plus 1/8. Yeah, how do you do that? Remember that little trick we do with the denominator? What's the trick? Right? Multiply this by 2 and this by 2. So from the arithmetic, this is like 2/8 plus 1/8. And yes, at the end of the day, that becomes what? 3/8. And that's just the constants. So ladies and gentlemen, this is a very famous process that's called, well, using the power reducing formulas to do what? To write in terms of a single cosine. That's the instructions. Write in terms of a single cosine. That's one cosine. So this is how we handle that, okay? And again, when will you see this kind of idea again? That's in Calculus 2. You might see it in some science classes, but definitely a math class called Calculus 2. Yes. Good question. So let's note something here, right? So in blue here, what do you have? You got the addition of these fractions. Okay, and in order to add fractions, they have to have the same denominator. Right? So if you guys remember from, well, wherever it is, right? I think they give you a formula like this. Let's do it this way. AC plus BC becomes what? A plus B over C. So you need, here's the key down here. These are called like fractions, same denominator. So the only way you can ever add fractions or even subtract, because it's used for subtraction too. So sometimes you'll see this plus minus, and that makes this plus minus. I'm not going to change it. So we can call this an algebra thing or arithmetic thing. That's an 8. So you might say to me, well, how do I add fractions with different denominators? Well, you're really supposed to find the LCM of 4 and 8. You go, what's the LCM, right? It's the least common multiple of 4 and 8. So you say LCM. What are multiples of 4? 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 16. That process goes on forever. That's just for the 4. Now, 1 times 8 is 8. 16, 24, 32. This process goes on forever as well. So the smallest common multiple here is actually, the least, the smallest is 8. That's the LCM. It's 8. So there is like a framework, and you say, well, what's the framework here? Okay, this is the standard way to do that. And you say, well, how do I get that 8 LCM? The only way you can do that is multiplying this by 2 and this by 2. That gets your denominator an 8. This will be a 1 and a 1. So you might say, does this give me the 1/8 I need? Yes. Or sorry, 2/8 for the first one. It does, 2/8, and this will be 1/8. And the answer is now going to be 2 plus 1 over 8. And that's actually how we got the 3/8 over here. Okay. So in some ways, if you know, oh yeah, you got to have the same denominator to add your fractions, you got to multiply the bottom by 2 and the top by 2. You know, and that's kind of where we got that idea. But this goes back into adding these fractions here. Okay, and then you say, well, all right, Mr. Judge, what if I have the following? Cosine squared times what? Sine squared. Again, they want you to write this as a single cosine. How do you do that, right? How do we write these things as a single cosine? So now you said, I think I recognize this first one, right? What was the power reducing there? 1/2, 1 plus what? Cosine double theta. What's going on? Do I need a new tip? And then over here, what's this going to be? 1/2. What's the difference? You guys know what the real difference? This would be minus. This is the difference here. So I'm going to color this orange. Oops. This formula is right here. This formula is right where? Here in green. Okay, so you got orange and you got what? Green. And you're supposed to do what here? Multiply here, right? Well, no, I mean, this means to multiply. It's okay. It's all right. When people first see this, I mean, I get excited and I'm going to have to go back and show you guys those formulas because you go, really? Yeah, that's the difference here, right? So in this case, you have plus, and in this case, you have what? Minus. So it's like they're very similar, but they only differ in sign. Okay? And again, this is good stuff. Like I said, you'll see these things kind of in your future. And remember now, you say, what do I do now? Remember, the order in which you multiply doesn't matter. So you're going to multiply the two fractions here, right? So I'm going to say, what's 1/2 times 1/2? Do you guys know what that is? That's 1/4. You get 1 plus cosine double theta. 1 minus what? Cosine double theta. And then you say, okay, Mr. Judge, what do I do over here? I'm going to say, you're going to do FOIL like you did before. But I want to remark about FOIL here. There's something interesting. Does anybody know what I'm talking about? What's so interesting about FOIL here? Do you guys know? Yeah, you get what? A plus B times A minus B. Is that true? Okay. And do you guys know what that happens in this case? A squared minus B squared. This is going back to that beginning algebra here. Easy breezy lemon squeezy. You guys know what I'm saying? This formula. So we're going to have to apply this formula now. So you get now what? 1/4. Now what is this going to be? 1 squared minus what? Cosine squared double theta, because that's the same exact term in FOIL. Okay, you guys okay with that? Why did I write that down again? Oh, sorry. I know why I wrote this down, because I know what 1 squared is. What's 1 squared? And this is just simply cosine squared double theta. Okay. Now you get to what? Distribute. Get 1/4 minus 1/4 cosine squared what? Double theta. Easy breezy lemon squeezy. So what do you guys do with this formula here? Remember, that's not a single power. What do? Do you guys know? You have to do what here? You're going to do a power reducing. What's this? 1/2. 1. When it's cosine, what do? It's plus. Now, what is double theta? What's that going to be? 4 theta. Okay, replace that there. Now, what do you guys get? You get 1/4 minus what? 1/8. 1 plus cosine 4 theta. What do you guys do here now? You're going to do what? You're going to distribute here. Okay? And when you distribute, what do you get? 1/4 minus what? Minus 1/8 cosine 4 theta. Okay? Now, I'm going to share this with you guys. You're going to have some arithmetic here. Right? That's the same arithmetic that we did kind of earlier. You know what's kind of nice again is it's actually the same denominators, right? So remember, if you're going to subtract fractions, what do you guys need again? We need the same what? And how do you do that? 2 times 2 down here. So I'm going to do the work. This is 2/8 now minus 1/8. And what does that give you? So we get 1/8 minus 1/8 cosine 4 theta. Did I make a mistake? I think we're good. Is that right? Yeah, we're good. I think we're good. Yeah, the sign changes because of that factor of a -1/8. Remember, here we're doing the what again? Here we're doing that distributive property, the algebra, right? But remember the term out in front here, this is negative, so it's going to change the signs. So there you guys go. No, you're writing this as a single what? As a single cosine. So you go, what do you mean single cosine? Yeah, you don't have to factor. You're done. In fact, in the calculus setting, this is what you need, this form. You know, so there is a setting in which you guys need to remember how to do some of these things. And then you say, well, does it get worse? Well, I hate to say it. I'm going to try this here. This is probably as bad as it'll get. Okay. This one is going to be as bad as it gets. Now, what do you guys think you're going to need to do here? Anybody have an idea? You guys guess? What do you think you're going to do? Yeah, it's going to be do it this way. It is a tongue twister. Okay, you guys are going to have this here. Okay, now I'm going to give you guys some algebra. You guys remember this? This is like saying a squared times what? A squared times a squared. What does that give you? 2 plus 2 plus 2, which gives you what? A to the third. I'm sorry, 6. What am I doing? 6. Okay. It's good to know arithmetic. 2 plus 2 plus 2 is 6. I apologize there, okay? So I'm giving you guys here now what this is. Let's color this purple. All right, you guys okay with that? So what do you do with the sign squared? Do you guys remember? What's this? Isn't that 1/2 what? 1 minus cosine double theta here. And then I have what? 1/2 times 1 minus cosine what? Double theta. You guys okay with that? And then what else do you guys have? 1/2 1 minus. So let me make some space. I hate when this happens. It's my biggest gripe. But at least I can move things around. You know what I mean? Okay. So what I'm going to do now here is this. Let me remind you guys. This is 1/2 times 1/2 times 1/2 because the order in which you multiply doesn't matter, right? So aren't you going to get 1/8? 1 minus what? Cosine double theta. 1 minus cosine double theta. 1 minus cosine double theta. So what I'm going to do now here is this. What should I do? Should I let you guys try this out? Should I leave you to the wolves? Is it too soon? Is it too soon to toss you guys to the wolves? Or you go, no, I'm not ready yet. I'm not ready to go out. You guys want to try that? All right, give you guys a few minutes to try it. At least try it, right? Remember, that's the most important thing, so that you guys can try this, okay? Give you guys a few minutes to try it out and see what you get. Okay, should we try this out? Maybe you said, maybe you guys went all the way through. Maybe you got stuck. It doesn't matter. We're trying to learn how to do this, right? So here's what I'm going to say to you guys. Okay, here's the approach. What do we use here? I think I'm using, did I have a different color? What color did I use? Purple? Oh, I don't know. I guess it doesn't even matter. You know what I'm going to suggest you guys do here? Use what here? Use foil here. Okay? Oh, shoot. Please. What just happened? Are we plugged in? This only happens if we're not plugged in. We are plugged in. Please don't tell me I need a new laptop. What happened here? Where's QuickTime? Okay. So here's what I'm going to do, ladies and gentlemen. I'm writing, but QuickTime's saying, you're not writing anything. Oh. Maybe today's a day we just leave and have breakfast or something. What do you guys think? There's some days where you just can't win. Oh, okay. Let me do this. I'll say QuickTime goodbye. Okay, you guys, we're going to come back. Where's our QuickTime? Man, come on. Yeah. Well, that's horrible. All right, I'm going to do this here. I have to reboot. The only thing is I'm going to reboot the iPad for those of you guys at home. Okay, we're going to go over this. Reboot. It's never happened before. It's only happened when this thing, the power is not plugged in. It looks like we're charging. Okay. All right, now there we go. All right, we're back. Sorry about that, ladies and gentlemen. Don't know what happened. Okay. So we're going to use foil here, okay? So notice we have the following. Okay. So notice we have the following here, okay? 1/8. Now remember, which formula do I use? Isn't this going to be what? 1 squared minus what? 2 times 1 times cosine double theta plus cosine squared double theta, okay? Times, here's what I'm going to do. I'm going to color this green because I don't have space. I'm going to say times the green because we're going to need some space, okay? We're going to need space here. So we get 1/8, 1 minus 2, cosine double theta, plus cosine squared double theta, times that green portion of 1 minus cosine double theta. This is that green portion here now, okay? Now, I'm going to recommend you guys do this here, okay? Here's my recommendation. Multiply, distribute the 1/8. You're going to multiply that 1/8 by every term here, right? And so here's what you're going to get. You're going to get what? 1/8. Now, what's 1/8 times 2? That'll be 1/4 cosine double theta plus 1/8 cosine squared double theta. Okay. Okay, and don't forget, I'm going to copy this. Oops. Paste this here. All right, you guys okay with that? And then we're going to do here, we're going to what? We're going to multiply. Yeah. All right, that's okay. Don't worry. I've done this a million times. This might be the first time you guys have done it, and that's okay. Right? There was a first time I've done it, and I looked at that and go, really? I got to do all that multiplication? Yeah. There's a couple of things you can do here. Okay? You say, what could I do? You know what I think I'm going to do? You see this cosine squared double theta? What are we going to replace that with? 1/2, 1, what? Plus or minus? Plus cosine what? 4 theta. Okay? Now this is in red. Okay? Don't forget, though, what's happening here. 1/8 is being multiplied to it. Okay? So here's what I'll do. What's 1/8 now times that 1/2 here? You guys know what you get? You get what? 1/16. 1 plus cosine 4 theta now. I'm just focusing on this portion so you guys know, okay? And then what does that give you? If I distribute now here, you get what? 1/16 plus 1/16 cosine 4 theta, okay? So you might say, what is this? Well, this is not the green. This is here. And then you have what out here? 1/8 minus 1/4 cosine double theta plus what? And then this is the green portion. Okay? Okay, you guys okay with that? That's the move. And then if I said to you, can you guys add these two fractions? Right? Let's do this here. Add these fractions here. 1/8, 1/16. Okay? This is a different, but it's similar. 2 times 2, is that right? Get the same denominator. You guys okay with that? So it's 2/8 or 2/16. Okay. 1/16. Is that 3/16? Yeah. 3/16. Minus 1/4 cosine double theta plus 1/16 cosine 4 theta. Then what do you multiply this with? What's green? 1 minus cosine 2 theta, right? Okay. That's the green portion. That's the move, ladies and gentlemen. So how you do these things, there's sort of a pattern to it that makes the algebra a lot easier. And that's what I had to learn, just like you guys, okay? So don't look at it and go, my God, I wasn't born knowing how to do this algebra. Nobody was. So you learn it this way. Now, here's another thing I'm going to say that I learned that you guys are learning. Okay, so notice you got 3 terms multiplied. This is like if I said to you in terms of algebra, you got, A plus B plus C times D plus E, right? This is the algebra. Now, I don't call this FOIL, I call this FOIL-ish. Let's do some FOIL-ish, okay? Because there's an S portion here. Do you guys know how to do that by algebra? I'm not saying you want to use this formula, but you want to use the approach, okay? Here's what I'm saying. You're going to distribute what? The D to these 3 terms, and distribute the E, multiplication, to these 3 terms. So how do you do that? Let me express this in terms of what you have here. This is what? AD plus BC plus CD. And then this is going to be plus what? This will be plus AE, okay, plus BE plus CE. Now, maybe you want to see colors instead. I don't know which ones to use. Maybe, see this D? It's multiplied to all the terms. Be D multiplied to all the terms, okay? That D is multiplied to all these other terms here. And then you say, what about the E? Well, the E gets multiplied to those terms as well, okay? Just so you guys can see this, there's the A, B, C, A, B, C, A, B, C. Now, FOIL-ish. This is essentially what you're going to be doing here. Now, we know what's nice about the number 1. 1 times everything is itself. So I'm going to say 1 times all these terms. What do you get? You just copy down the terms. 3/16, right? Minus what? 1/4 cosine 2 theta, right? Plus what? 1/16 cosine 4 theta. That's 1 times all those terms, okay? Now what are you guys going to do? Minus cosine. I'm going to erase this, okay? So hopefully you guys see the point there. It's FOIL-ish. Okay? So you're going to multiply this term with everything as well. Okay? But you might say, I'm going to run out of space. Put it under the other terms. Here's what I mean. You see this negative cosine 2 theta times 3/16? That's going to give you negative what? 3/16 cosine of what? 2 theta. Put it below that term, okay? This will make everything easier. And then you got a negative cosine 2 theta times a negative 1/4 cosine 2 theta. Well, that makes it a plus what? 1/4 cosine squared what? 2 theta. Okay? And then you say, well, what? Well, then what do? Do this minus cosine 2 theta times a plus 16 cosine what? 4 theta. What does that give you? It gives you minus 1/16 cosine 4 theta, okay, times what? Cosine 2 theta, okay? So we're going to have some work to do now. This is multiplying everything. I'm going to simplify a little bit here, okay? You see these two terms here? Cosine 2 theta, they're like, is that right? So I'm going to actually do this. I'm going to multiply this by 2, and you end up with what? 3/16. That's 2/16 minus 3/16 is minus what? 5/16 cosine 2 theta. So I'm just writing down that term, and I just added here or really subtracted. So that's negative 2/16 minus 3, that's negative 5/16 cosine 2 theta. Oh, sorry. Good job. So that's going to change this number. What is that then? Negative 7. Good. Apologize. Okay. Now you're going to say what? Plus the 1/16 cosine 4 theta. We just wrote this term. So what you're now left with to deal with is this. 1/4 cosine squared 2 theta minus 1/16. We're going to write down this over here. Okay. Cosine 4 theta, cosine of what? 2 theta. So I'm just bringing down the other terms here. Okay, you guys okay with that? Now I'm going to say this to you. What do you guys do with cosine 2 theta now? Right? Yes, we replace that with what? 1/2, 1. I think that's 1 what? 1 plus cosine of what? 4 theta. So the work right in here now. Remember, what does this become? 1/4 times 1/2 gives you what? 1/8. 1 plus cosine what? 4 theta. Distribute. We get 1/8 plus 1/8 cosine 4 theta. That's the work right in here. What do we do with this? Times 2 times 2. Doesn't that give me my 16th? You say, why would I want to do that 16th here? Because we have a 3/16, then we have a what? 2/16. What does that give you? Gives you what? 5/16 minus 7/16 cosine what? 2 theta. I'm just going to write down all the terms. 1/16 cosine 4 theta. Now this will be again plus what? We already added these two. 3/16, 2/16. So I'm going to add that plus 1/8 cosine 4 theta, right? And then you got that minus 1/16 portion. So minus 1/16 cosine 4 theta. Yeah. Okay, you see this constant here that we have here? You see this 3/16? 3/16 plus 1/8. So you can multiply that by 2 and by 2, and that gives you the 5/16 there. So what always kind of sticks out like a sore thumb are those constants that you have to add. And in all honesty, now you just have to do what? What do you guys think you just have to do at this point? Right there. Combine like terms. But what's the problem with the numbers in front? It's 2. So you get 5/16 minus what? 7/16 cosine 2 theta plus what? 3/16 cosine 4 theta minus 1/16 cosine 4 theta cosine 2 theta. And that's pretty much it. You say, why is that it? Because what are the powers? See all these powers? What powers go there? Do you guys know? That's a 1. It's a 1. Don't they want us to write it as a single what? Single power is a cosine, they said. Remember the original instructions? A single power of cosine. So to make a long story short, to summarize what I want to say here, here's my summary, ladies and gentlemen, that when they give you the 6th power, there's going to be some what? Work. If they give you a 4th power, there's going to be less work. You're just going to use FOIL. If they're going to give you a 2 power, they're not. But if they did, you just write down the identity. Okay? So this is the kind of long process associated with what? When they give you the 6th power here. And in a calculus course, do you think they'll do that? Yeah. So I've seen that 6th power in a calculus course. And, in calculus, they do also an additional step, but I won't do it here because the instructions are clear. Write as a single power of what? Cosine. All right, you guys okay with that? There you go. Okay, you guys okay with this one? Now, here's what I'm going to remark to you guys here, right? So here's what's happening. Here's what's going on. If you guys take a look at my website, not my website. I don't know if you guys get this in Canvas here, but what's going on Tuesday? Do you guys know what's happening on Tuesday? Let me go here, 241. First of all, I think I have a typo to talk about. So you guys know? Yeah, that's one thing I want to remind you guys. Let's go look at the calendar. I have a typo that I have to fix on this thing. Yeah, Veterans Day is on the 11th. It's not on the 10th. So I apologize. So we have class on Thursday. We have class on Thursday. I sent that as an announcement in Canvas. So we do have class on Thursday. I sent that as an announcement in Canvas. I have to say it 3 times. Right? Because what happened when Jesus wanted to make a point? Anybody here read the Bible? He had to say things 3 times. So, Friday, November 11th is the campus is closed. It's not closed on the 10th. We are open. We have class. Okay. But the following week, what do you guys have on Monday? Test what? 2 or 3. And you go, oh my God, Mr. Judge, I got a test. My life is over. Oh, poor me. Oh gosh. I'm already hearing it in some of these other classes. Oh my God, you guys have no clue. Oh my God, whatever. But you know what I did last night? What do you guys think I did last night? You know what I posted? I posted a study guide. Now, I mean, I might change a little bit of it, just so you guys know. I put a study guide, and so just kind of, I think by Thursday, I might not change all of it, but just a small bit. We'll see. I have no idea. But the study guide is longer than your test. You guys know that? So you guys are always longer. There's no way you're going to be able to do this in whatever time we do it in. And yes, I'll come in early again because I'm in here early anyway. So if you guys say, "Hey, Mr. Judge, I wouldn't mind a little extra time in the morning if you could," absolutely, I'll be here. We'll let you guys have some extra time. But I do have that study guide already posted. I posted it last night. So you guys can take a look. It's like law of sines, law of cosines. There's some things here. I might change a little bit of it, but it's there. Okay, so some of these things you might say look kind of familiar. These are topics that we covered. Some of these topics here. Oh, there's some proofs. What else? Oh, we've seen that double angle, half angle stuff. Oh, we haven't seen that, so we'll see what we do. I might remove that. Oh, and we haven't seen these. I might remove that too. So I might be changing some of this for you guys so you guys know. I need to put power reducing formulas. You guys see what I'm saying? So just be aware. I'll let you know. At least the beginning part you can do. But do the stuff that you know we covered, and then I'll modify and change it by like Thursday or Friday. That's what I get to do on my Veterans Day is work. Okay? Well, people think it's kind of like I talked to the janitor. She goes, "Oh, aren't you glad it's going to be Thursday tomorrow?" And I'm like, well, not really, because I work like day and night, 7 days a week practically. And so it's not like, oh, I'm off. Trust me, I have meetings later today. Oh my God, I got to yap and hear people yapping. And sometimes I just want to scream. I was thinking, I'm just going to cancel my day and I'm going to go have some breakfast and go home. But I can't. So all I'm saying is, I'll be working and I'll be changing some things for you guys. But I'll let you know in Canvas. You get an announcement, okay? Yes. Yeah, actually, they're right here. Good question. Are the power reducing formulas on the formula sheet? Remember, I'll let you guys use the formula sheet on the test. And you say, well, where are they? They're there because it's very a big deal. See, they're the half angle identities. Like whoever did this worksheet, they're kind of weird. They're in the upper right corner. Those are the power reducing. They don't even label it power reducing. And I wouldn't even call it half angle because I don't even see a half angle. Do you guys see what I mean? So whoever wrote that, and I got it online because I remember looking for a cheat sheet and I'm going, okay, what do I get? I got this online. So, just to kind of keep you guys all informed that, I'll be changing that study guide, but I got some stuff up for you and, we'll see how that goes. And yes, I'll come in early. Anyway, what do you guys think? Does that look scary? Hopefully not. At the end, like I said, I'll change some things. So that's what's going on. So the 6th power for power reducing is going to be a lot of work and a lot of arithmetic. But you see it in a calculus course. They will give you an integral of like sine of the 6th power. And you go, what? I got to do what? I got to do all of that, and then I have to integrate. And the answer is what? Yes. But you guys are not there yet. You will be. Don't worry. You'll get there. But I want to demonstrate this to you guys here so that you can see it and do some. But cosine of the 6, sine of the 6, pretty tough. A lot of arithmetic, a lot of algebra. But it's doable. If I can do it, you guys can do it. That's how I think about it. Because I was a student once too. You know what I had to do? My homework every day and study every day. And I have another thing to let you guys know. I work every day too. Even when I go home, I work. And even on Fridays, I work. And the weekends, I work. And then, my wife's like, oh, he's working again. He's behind that computer. So this kind of stuff just doesn't change. You want to get used to it. Get used to it. It doesn't change. So, I'm just applying what I did as a student now, even as an instructor. Okay, so it can be done. You guys can do it. If I can do it, anybody can do it. So, okay, we'll see you guys tomorrow. Okay, have a good day. Take care and stay safe.